Okay, so this is one of several videos about scientific notation. Scientific notation you probably did in math class before, but why do we use scientific notation? Because in science, we need to be able to write numbers, really big numbers, or really small numbers in a way that's easy to read. For example, here is the number of carbon atoms in 12 grams of carbon. This is really the number. Is can't even read this. 60220000000. Okay, that many. Okay, a lot. Now, I don't even want to count how many zeros that is. It's a lot. So how in the world would we write this such that it's easier to read? We're going to write it like this. Remember this format in math? 6.022 times 10 to the 23rd. What a nice number. A lot easier to read than the top number. So that's the reason why we have scientific notation. It's a lot easier to read this number than it is that number. How do we translate this to this? It'll be in another video, but we're going to move the decimal point over 1, 2, 3, 4 to the 23 times, hence to the 23rd power. 23 times to 6.022 times 10 to the 23rd. That's why we do scientific notation, because this number is too hard to read. That a lot easier. Okay, what about if I want to know the mass of a single carbon atom in grams? Here it is, 0.0000199. Okay, this makes me dizzy looking at how many zeros there are. I don't want to look at that. Is there an easier way to do that? 1.99 times 10 to the minus 23. A lot easier to read. Not so easy to read. A lot easier to read. Not so easy to read. So the reason why we have scientific notations, just it makes it so much easier to read these numbers, as well as to write it. How do we go from here to here? Again, you might already know, because you should have done this in math class, and there will be another video on this, but we'll move the decimal point over 1, 2, 3, 4, 23 times until we get to 1.99 times 10 to the 23. The format of scientific notation is always this. Some number n times 10 to the n power. Hold on. This capital N can only be between 1 and 10. Oops, my face is in the way. So that number in the front, this capital N, can only be between 1 and 10. So we cannot have, this one here cannot be 199. This number here cannot be 6,022, because the number in front must be between 1 and 10. It could be 1, okay, but it can't be 10, okay, from 1 inclusive to, but not equal to 10. So between 1 inclusive to less than 10. So N, capital N, must be between 1 and 10. So 1.99, not 19.9, not 199, and not 0.199. 6.022, not 60.22, not 6,022, not 0.6022. It has to be between 1 and 10. The other lowercase n is going to be some sort of positive or negative integer. So positive or negative integer. How do I know if it's positive? How do I know negative? Well, first of all, what is the integer? It's how many times we move the decimal point to get to 6.022. How many times move the decimal point to get to 1.99? You must move the decimal point over 23 times here or 23 times here. But how do I know if it's positive or negative? I usually just remember it. Some people say move to the left, move the decimal point to the left, positive. Move the decimal point to the right, negative. If that works for you, use that. For me, I just think positive, big number, it's big number. Negative, small number. Positive, big number. Negative, small number. Positive, big number. Negative, integer, small number. So that's how I usually remember it. Or again, you could say move the decimal over to the right, negative, move the decimal over to the left, positive. Whichever way works for you is the same. Okay, so if I wanted to convert this into scientific notation, I'll move the decimal point again. I can either move it to the left or I can move it to the right. But I do want to move the decimal such that the number is between 1 and 10. And so if I move it to the right, well, I'll just make the number bigger. If I move it to the left, actually that would make sense. Let's move it to the left. Why? Because remember, I want that number in front to be 5.687 or 5.68762. So I'll move it to the left. And if I move to the left, the exponent part will be positive, or you can say this is a big number. I'll move the decimal point over 2 times, move it over 2 times, or times 10 to the 2 power, or second power. 5.68762 times 10 to the 2. Let's look at this number. Ooh, that's a pretty small number. Guess what? I think the integer is going to be, that number, the exponent part number, is going to be a negative number. I'm going to have to move the decimal point to the right, meaning that exponent part is probably going to be a negative number. And how many places do I have to move it? 1, 2, 3, 4, 5, 6. I think I have to move it 6 times. So I'm going to move it 6 times. 10 to the minus 6, 7.72 times 10 to the minus 6. And that's how we put numbers into scientific notation. You want to move it to the left, positive. Move it to the right, negative. Or I just see it as big number, positive. Small number, negative. Big number, positive. Small number, negative. Whichever way, move left, move right. Whichever way you want to do it, it's the same. Okay, so that's it for this one right now. We're going to do other examples of determining or writing numbers into scientific notation next.